Alright, welcome back. In this video we're going to go over some basic algebra, and we're going to talk about the terms that we're going to use in algebra, and also how to simplify expressions and solve some equations. So first off, a little bit of vocab here. First off, you know the word variable, and that's going to stand for a letter that is standing for a number. A lot of times we use X, or we use Y, or we've used N or P when we're talking about proportion and percentage problems. A constant is a known number, like 2, 4, just any regular number. It could be a fraction, like 1/2. A coefficient is a number that's in front of a variable, and that means that that number is being multiplied by the variable. So for example, 2x, the 2 is the coefficient, and it's being multiplied by some unknown variable x. We have 2 times x. If I wrote 3y, that means 3 times y. A term is part of an algebraic expression that's separated by a plus sign, but we're going to see that anytime we have a subtraction sign, we can rewrite that. So for example, if I have x minus 4, I can write that as x plus a negative 4. So just because it says separated by a plus sign, anytime we have a minus sign or subtraction sign, we can change that to adding the opposite so that we can look at the terms. Like terms are something that we're going to use. We need to know what like terms are so we can combine them together. Like terms have the same variable part to them with the same exponents. So we're going to look at an example here. So think about 2x squared plus 3x minus 6 plus 4y plus 6x minus 7y plus 8. Think about how many terms does this have, and think about what the like terms are and how we can simplify this. So in this example, we've got 2x squared. Now what I like to do is I like to underline them. So that's the only x squared that I see here. So I'll underline it once, and then I come across 3x. So we're going through our example here, 2x squared plus 3x minus 6 plus 4y plus, like I said, an algebraic expression, we can rewrite this. So let me do that first. We got 2x squared plus 3x. We can change all the subtraction to adding the opposite. That might make it easier for us to count the terms. Plus 4y plus 6x plus negative 7y plus 8. And then we can count the terms, and we can see it has 1, 2, 3, 4, 5, 6, 7 terms altogether. And now we can look for the like terms. And let me get a different color here. So we've got a 2x squared. I'll underline that once. There's no other x squareds with it. We've got 3x, and we can combine that. That's like terms with the 6x. I'm going to underline those twice. We've got a constant of negative 6, and another constant over here of 8. And then we've got 4y, and we've got negative 7y. So this little underlining trick, or you could use like different colors, will help you to figure out which terms are like terms and which ones we can put together. And now when we put these together, I can put down the 2x squared first, and then 3x plus 6x, we add the coefficients together. So 3 plus 6 will give us 9x's. Notice that the variable part does not change when we combine like terms. So if it's x and x, we've got 3x's and 6x's. We put them together as 9x. And then we go to, let's do the y's next. So I've got 4y minus 7y. So I can write that as plus a negative 3y. And if I wanted to, I could also write that as minus 3y, like this. And lastly, our constants. Usually the constants will go at the end. We got negative 6 plus 8. So we can write that as plus 2. And so now we've simplified our expression down to 4 terms. And usually we'll put the x's out in front, and then the y's, and then the constants at the end. For the most part, in this course, we're going to be dealing with just x's and constants, or one variable with a constant. So we're not going to see so many terms here with different variables and different exponents. But this gives you an idea of what like terms are and how we can combine them. Now there's some basic properties. You don't have to have these memorized, but we're going to be using them quite a bit. So commutative property just means that we can change the order. So, when we're adding or for multiplying, it doesn't matter that the order that we do it. A plus B is the same as B plus A times B is the same as B times A, and this works for all the numbers, and it works for the variables with the numbers as well. Then we also have associative property, and this allows us to change the grouping. So if I have parentheses around the first two terms, A plus B, and then I add C later, that's the same as if I decide to add B plus C first and move the parentheses around those two, and then put the A out in front. And this associative property also works with addition and multiplication. Notice that these properties don't work with subtraction or division. And the last final property, probably the most important, is the distributive property. And we're going to be using this quite a bit to simplify expressions. So this is a property of both addition and multiplication. We can write this as A times the quantity of B plus C. And that means we're going to distribute the A is going to get multiplied by the first term, A times B. And then we're going to add on A times C. So with numbers, for example, 2 times the quantity of 3 plus 5. Normally, this would tell us to add the 3 and the 5 first, and then multiply by 2. But we can distribute the 2, and we get 6 from the 2 times 3, plus 2 times 5 is 10, so we get the answer of 16. This is especially useful when we have algebraic expressions, and we have a variable, and we can't necessarily put these two together. I can't combine the 3x with the negative 4 here, but I can distribute the 2, so 2 times 3x is 6x. And then 2 times negative 4 is going to give me negative 8. So now we've simplified that using distributive property. So in this quiz, in this lesson, we also have to evaluate. We've done some evaluation before. And so just to remind you, whenever we see algebraic expressions and it's going to tell us to evaluate, it's going to tell us the numbers to plug in. And here it's saying y squared minus x. We're going to take out the y, put a parentheses there, square it, minus x, take out the x, put a parentheses. I like to put these parentheses in because if you're putting it in the calculator and you leave out the parentheses, sometimes it causes problems, especially when you're squaring a number like we are here. And if it's a negative, and what goes in for y, that's going to be negative 4. And what's going to go in over here, that's negative 1. And then we can just follow the order of operations, PEMDAS, negative 4 squared is going to be negative 4 times negative 4 is 16. And then we do that first, and here we're doing subtraction. Actually, we got 2 negatives, so that's the same as adding the opposite. So 16 plus 1, we get a 17. Now, if you put this in the calculator and you do not have the parentheses there, and you type in something like this, it's going to only square the 4 and not the negative 4. So you get a different answer. So got to make sure you have the parentheses here, especially again if you're using a calculator. Let's do another quick example. Let's skip down here to number 7 because this has the absolute value bars to remind you again what absolute value is. And that's going to tell us to take the absolute value of x. We'll plug negative 2 into there. And then we've got an x out here. That's a negative 2 times parentheses negative 4 minus z. Z is positive 2. And so now we can simplify this. We do order of operations, so there's nothing to do inside the absolute value. So we go over here to these parentheses, and we can simplify that. Now you could also distribute as well, but we can, since those are just numbers, we can put those together. We get negative 6. And from there, we've got the absolute value of negative 2 plus negative 2 times negative 6. That's being multiplied, so that gives us 12. And lastly, we can take now the absolute value of whatever's inside here. That gives us 2 plus 12, and we end up with 14. So I'm not going to spend too much time on evaluating because we've done that in some previous lessons. All right, so when we're simplifying expressions, it means that we are probably going to get a new expression that looks a little bit more condensed than these. We have 2 tools, so we're going to combine like terms, and we are going to distribute. And sometimes you might have to do these things more than once. So those are our 2 tools that we have for simplifying expressions. So for number 1 and number 2, the only thing we can do here is combine like terms. And again, I'm going to use my underlining technique here. So I got a constant of 6, I got a constant of -9, and then I've got a variable term of 10n, another one of n. And if you just see a variable by itself, it does have an invisible coefficient, so you could write a 1 there if you wanted to. And now we can combine these together. I like to put the variable term first, although it doesn't really matter. So you can write this as 11n minus, so 10n plus 1n gives us 11n, and then 6 minus 9, what does that give? It's going to give us -3. So that's one way to write it. Of course, we could also write it as -3 plus 11n. That would be fine as well. Either one is correct. I would say that the first way, though, is usually preferred. Usually you're going to put the variable terms first and the constants towards the end. Number 2, same thing, underline the like terms. So we've got n, or 1n minus 9n. So we can put those together. That gives us -8n. And then we've got -8 plus 10, and that's going to give us 2. Notice that that's our final thing. We can't combine them any further. So we've got -8n plus 2, or again, we can write that as 2 minus 8n. For number 3 and number 4, you have to distribute. So when you got a number out here in front of the parentheses, that number is being multiplied by the whole group. And we're going to multiply by each term on the inside. So we got 8 times n is 8n. And then we have to remember to multiply by the second term. 8 times -8 is -64. And again, we can't combine those because they're not like terms. If we distribute here, 5 times 2x gives us 10x. And 5 times -9 gives us -45. We can also distribute when you have a negative number. So watch your signs. If you see a negative number in front of parentheses, you're going to take that negative with the number. And -4 times 9 is -36. And that negative is also going to get multiplied in here. -4 times -8r is a positive 32r. Same thing with number 6. -5 times 4 is -20. And then -5 times 6x is -30x. Now we get to some that are a little bit more complicated. So here's where I said you have multiple steps. So you might have to distribute and combine like terms, or maybe distribute twice. So for number 7, looks like we have to distribute and possibly combine like terms. So let's start by distributing. We got 10 times 10x is 100x. 10 times 2 is 20. Bring down the -1. Now we can combine like terms. 20 minus 1, we can put those together, and we get 100x plus 19. Here, we got a minus sign in front of the parentheses, and when you have that, think of that like a -1 in front of the parentheses. So that -1 is going to get distributed. That negative is going to get distributed to the everything else. This part here, -9x, we don't need to worry about right now. So -1 times 6 is -6, and -1 times x is -x. And what are our like terms? -9x can combine with a -x to give us -10x. So we get -10x minus 6. And of course, with either of these, you could write them in a different order here. So -6 minus 10x would be fine as well. All right, for 9 and 10, we have to distribute twice. So let's take a look at this. We have 8 times 1 is 8. 8 times -3v is -24v. And then here we've got 7 times v is 7v. And 7 times -9 is -63. And now we can combine like terms. The -24 can be combined with the 7v to give us -17v. And then the 8 and the -63 will combine to give us -55. And for number 10, same thing, except now we've got some negatives to worry about. So we got -5 times 4v is -20v. -5 times 1 is -5. Again, with the negatives, watch your signs. Make sure you take the negative inside as well. So this is a -4 times 1 is -4. and negative 4 times v times negative v, a negative times a negative is going to become a positive 4v. And combine like terms, so here we have negative 20 plus 4 is going to be negative 16v, and then negative 5 minus 4 is going to give us negative 9. Okay, so now we're going to go through types of equations. So the first type of equation that you're going to have are just simple one-step equations. So with these, just think about the step that's involved and go backwards. We've already done several of these, so I don't think I have to go through all these, but you could be adding or subtracting, multiplying or dividing, and you just have to do the opposite operation. So if here, this is saying that we have an x, some unknown, and we're subtracting 10. So what is the opposite of subtracting 10? Well, the opposite would be to add 10. So we're going to add 10 to both sides. We want to keep this equation balanced. And when we do, negative 10 and positive 10 would cancel out. And then negative 1 plus 10 is going to give us 9. You should always be able to go back to the original and plug in your answer to see if it actually works. So if we plug that 9 back in for x up here into the original equation, we'd have 9 minus 10 is equal to negative 1, which is true. So we know that this answer works out. We can also do this with multiplication. So here, this for number 3 is telling us negative 14 times k is equal to 280. So k here is being multiplied by a negative 14. So what's the opposite of being multiplied by a negative 14? Well, we'd have to divide by negative 14. So we're going to divide both sides here by negative 14, and that's going to give us k is equal to negative 20, I believe. So, yep, because we got k equals negative 20. And how can we check it? Let's see. We plug it back in, negative 14 times negative 20. That does come out to a positive 280. So it checks out. And you might be wondering what to do if you have some fractions like this. Let me write up a different problem here. So imagine I got like 3/4 is equal to 2/3 times x. Well, here I want to get the x by itself, and it's being multiplied by 2/3. Now we can divide both sides by 2/3, but dividing by a fraction is the same as multiplying by the reciprocal. So a lot of times we're just going to flip this guy around, 3/2, and multiply both sides by the reciprocal of the coefficient. So that here, the 2/3 and the 3/2 would cancel out, and we just end up with our 1x. And when we have 1x, we can just write that as x. And over here, we have 3/2 times 3/4, and we can multiply 3 times 3 is 9 over 8. So we get 9/8 for an answer. Now we get to some multi-step equations, and for these, I think it's easiest if you think about what is being done to this variable and think about how to work backwards. All right, so here we just have 1m. It's over here by itself on the left, and it's being multiplied by negative 2. So let me take some notes here. So we're multiplying by a negative 2. And then after it's being multiplied by negative 2, we're adding a 9 to it. So we want to reverse this process, go backwards, and do the opposite, the reverse operation. So if we go backwards, the last thing that was done is adding 9 to it. So we got to get rid of that first. What's the opposite or the inverse of adding 9 is to subtract 9 from both sides. And when we do, that's going to give us negative 2m is equal to 30. And then the first thing we did to the m here was to multiply by negative 2. So now we have to get rid of that negative 2. And the opposite or the inverse of multiplying by negative 2 is to divide by negative 2. So now we have m is equal to negative 15. So that is our answer. When we're solving equations, we're going to get a number most of the time, unless it's, a no solution type of thing. So you should be able to go back into the original and see if it actually works. So you can always check your answers with these. Plug it back in for m. We got negative 15 in there. Negative 2 times negative 15, if we add 9 to that, yep, that indeed comes out to 39. Now for number 3, I know what you're thinking. You see this and you probably just want to distribute right away, and maybe your other teachers, when you had them in algebra, said, oh, always distribute first. That's not always the case. You don't need to do that. So again, if you think about what the story is with A, what's being done to it, we're taking A and we're adding a negative 1 to it. So we added negative 1 to it. And then after adding negative 1 to it, it's being multiplied by negative 6. Or sorry, by positive 6. So if we take these steps and we go backwards, doing the opposite, we still should be able to get the A by itself. So watch this. Instead of distributing, I'm just going to solve this by dividing both sides by 6. If I divide these by 6, this 6 and this 6 would cancel out. I've got negative 1 plus A. And then over here, that comes out to negative 15. And we want to get rid of the negative 1 next. So we'd add 1 to both sides. And we've got A is equal to negative 14. Now, if you do distribute, you're going to add an extra step there. Now, you can do that, but this way is a little bit quicker. And this method also works pretty well when you've got new types of equations that you're not sure what to do. So, imagine you have an equation like this. 2 equals r minus 1 over 9. Here you got like a fraction with a variable in it. But again, just focus on what is being done to this r. So if we look here on the right, r, it tells us r minus 1 divided by 9. So the first thing that's being done is minus or subtract 1. And then we are going to divide by 9. So again, if we work backwards, doing the reverse, we want to get rid of the dividing 9 first. So what's the opposite of divided by 9? It's to multiply by 9. So we just multiply both sides by 9 first. That's going to give us 18 on the left. And these 9s would cancel out. And we just have r minus 1 on the right. And then we just add 1 to both sides. It's as simple as that. We got 19 equals r. Now, if you don't like that method, I mean, you could set this up as a proportion. So if you see that one side is a fraction, the other side is not a fraction, well, make both sides a fraction. And then you can just cross multiply and divide and solve it that way too. All right, here's the steps to solving multi-step equations. So first step is to simplify each side, and we have 2 tools to do that. Again, we can either combine like terms or use distributive property, or sometimes you have to use both. So check the left side of the equation, check the right side, and see if you can simplify any of them. Step 2, move all the variable terms to one side by either adding or subtracting those variable terms. Usually we try to move the variable terms to the left side, but sometimes if they're on the right side to begin with, we just keep them there. Step 3 is to move all the constant terms to the other side by, again, either adding or subtracting. So usually those will end up on the right side. Step 4, we want to divide by the coefficient of the variable. That's the number that's being multiplied out in front of the variable. And then we should have our answer. So step 5 is to check our solution. So here's some examples. And number 1, oops. For number 1, we look at the left side. There's nothing to simplify there. We look at the right side. Okay, we can simplify this a little bit. So we go ahead and distribute. And that's going to give us negative 4n minus 6n minus 36. Over here we have negative 116. We can combine like terms again. So that gives us negative 10n minus 36. And over here we have negative 116. Okay, so step 1 is done. We simplified the left and simplified the right as much as we can. Now we go to step 2, move the variable terms to one side. Now here we only have one variable term, and it's negative 10n. It's already on the right by itself, so we're just going to keep it there. That means we're going to move all the constants to the left side. So I need to get rid of the negative 36 over here on the right. And I'm going to do that by adding 36 to both sides. And once I do that, I've got negative 10n here because these will cancel out. And negative 116 minus 36 is going to come out to Oh, and negative 116 plus 36 is going to come out to negative 80. And now we can divide both sides by negative 10. And we'll get our answer of n equals 8. So we think we have our solution. And step 5 is to go back and plug that back into any variables. So we got negative 116 equals negative 4 times 8 minus 6 times 8 plus 6. So you can see that the 8 is going in for that end, the 8 is going to go over for that end, and that should check out. That looks good. So there's our answer. Number 3. So here's another equation. And this one's got variables on both sides, but we're going to start it the same way. So step 1, simplify the left. Okay, done, simplified. Simplify the right side. Okay, again, that's pretty much done. So now we want to move the variables to one side. Which side should we move them? Well, let's try to move them all to the left side. So I'm going to get rid of these on the right, and I'm going to subtract 6k here. If I subtract 6k from the right, I've got to subtract 6k from the left. That's going to give us 14 minus 12k equals 2. And then now I want to move all the constants over to the right side. So this 14 I have to get rid of. I'm going to subtract 14 from both sides. So that gives me negative 12k equals negative 12. And then we are going to divide by the coefficient, divide by negative 12, divide by negative 12. And we get k is equal to 1. So that's how we're going to do that. Number 5. This one has fractions. And you could do the same thing with fractions, but I'm going to show you a little way to get rid of the fractions. So the trick with the ones that have these fractions in it is to find the LCD, the least common denominator. So if you're looking at the denominators here, we got 2, 5, 40, 2, and 8. Now when you have fractions, first off, I'm going to write all the numbers as fractions. If I have any fractions at all, if I want to use this trick, I'm going to write these all as fractions, no mixed numbers. So if you have a mixed number, you got to change it to an improper fraction. And if you have any whole numbers here, like plus 5b or whatever, I'm going to write that as a fraction over 1. But this one just has all fractions here, 2, 5, 40, 2, and 8. Those are the denominators. So we want to look for the LCD. So what is the LCD for 2, 5, 40, 2, and 8? Well, it looks like 40 is going to work. So what I'm going to do is I'm going to multiply every term here by 40. So I'm going to multiply this by 40, I'm going to multiply this by 40, this by 40, this by 40, and this by 40. Now, you don't have to do it this way, but it'll make it a lot easier if you're doing it by hand. And now what I'm going to do is I'm going to take the 40 divided by the bottom number. So 40 divided by 2 is 20. 20 times 1, that's going to give me 20b. Go to the next term. 40 divided by 5 is 8. And then 8 times negative 12 is going to be negative 96. Go to the next term. It's a negative. 40 divided by 40, these cancel out. I got 1. 1 times 33, or negative 33, is negative 33. And the next term, 40 divided by 2 is 20. Multiply by the top, 20 times 3 is 60b. So make sure you keep the variables there where they go. And then the next term is a negative, and we got 40 divided by 8 is 5. 5 times 11 is negative 55b. So after you multiply by the LCD, all the fractions should be gone, and then you could proceed like we did on the previous examples. So let's go up here. We're going to combine like terms. So nothing to do on the left side. We got 20b minus 96. On the right side, we can combine the 60b and the minus 55b to give us 5b, it looks like, minus 33. And now I want to move all the b's together. So I'm going to subtract 5b from both sides, subtract 5b over here. And that's going to give us 15b minus 96 equals negative 33. And I'm going to move the 96 over, add 96 to both sides. So that's going to give me 15b equals negative 33 plus 96. 6 minus 3 is 3. 9 minus 3 is 6. And then 63 divided by 15. I think that comes out to a fraction, but I can reduce it because 3 goes into both of those. So 3 goes into 15. If I divide this by 3 over 3, it'll simplify it. 15 divided by 3 is 3. 63 divided by 3 is 21. So we could write our answer as 21 over 5. Or we could write it as a decimal of 4.2. Or you could go back and write it as a mixed number as well. But I think I prefer the fraction, 21 over 5. Although if you wrote it as a decimal, I would not count that wrong. Be careful with fractions in equations. If you if you had an equation that had like a 1/3 in it, and if you're writing that as a decimal, 0.3 is not going to cut it. If you change the 1/3 to a 0.3, 1/3 is not 0.3, it's 0.3 repeating. So for decimals that are repeating, it's probably easier just to work with the equation as fractions, like we did here. You're only going to see one of those on the quiz, so maybe I'll do a couple more examples. So let's go through 2, 4, and maybe the setup for number 6 at least. So for number 2, again, first step is to simplify. So we're going to simplify it. We get 32a. Distribute. Here we get 4 plus 4a equals 112. So make sure you simplify the left side, simplify the right side, and then we can simplify it a little bit more. We get 36a plus 4 equals 112. Now again, for this one, the a is on the left side there. We want to keep it there. We want to move the constants over together. That gives us 36a, and then 112 minus 4 is going to be 108. And we're going to take 108 and divide it by 36. And let's see what that gives us. And that comes out to 3. So we get a is equal to 3. All right, so let's try another one. So for number 4, let's erase this. All right, so for number 4, again, we can't simplify anything on the left. On the right side, we can combine like terms. So let's put these two together. So it's going to give us 5p plus 4 equals p, 1p. Actually, negative 1p, sorry. So we got negative 7 plus 6 is negative p, minus 14. Got to be careful when you're solving these. Add p to both sides. That's going to give us 6p plus 4 equals negative 14. Subtract 4 from both sides. 6p equals negative 18. Divide by 6, and we're going to get p is equal to negative 3. And again, if you plug that negative 3 back into the original for all of the p's, you should find out that the equation is true. And for number 6, this one again has some fractions. Before you use the LCD trick, you're going to have to change it a little bit, because remember, if it has mixed numbers or if it has any whole numbers, you want to change those all to fractions and mixed numbers to improper fractions. So let's rewrite this first. So we've got negative 76v minus 1/3. And then the 2 7/8, we want to change that. 2 times 8 is 16. 16 plus 7 is 23 over 8. And then here we got negative 43 over 24. And I'm going to write this v, which is a 1v, as 1 over 1v. So I have it as a fraction. Now we're going to find the LCD. We need the LCD of 6, 3, 8, 24, and 1. So what number is divisible by all of those? Well, we got to look at the largest one first and see if that works. And here, 24 does work. So we're going to multiply everything here by 24. So let me just write a 24 in front of each of these. So we got 24, 24, 24, another 24, and another 24. And then we go through and we try to cancel and reduce here. So we take the 24, the LCD, divided by the bottom number, multiply it by the top, as we did previously. So you could even do this by hand, or you can use a calculator. 24 divided by -6 is going to be -4. -4 times -7 is going to be -28v. Make that a little bit clearer. -28v minus 24 divided by 3 is 8. 8 times 1 is 8. 24 divided by 8 is 3. 3 times 23 is going to be 69. Then we go over here. 24 divided by 24 is 1. So it's going to be -43. And that doesn't have any v's with it. And then we got 24v here. On the left here, we can combine some like terms. So we can put the -8 and the 69 together, it looks like, to get plus 61. And now we want to move all the v's together. So I think this is 24v. So we want to subtract 24v from both sides. So that's going to be -52v plus 61 equals -43. And we're going to subtract 61 from both sides. And that's going to give us -52v equals -104. And after dividing by -52, it's not too bad because it just comes out to 2. So v comes out to 2. And again, you can go back and plug it in and see that it works. So that's solving equations. Let me know if you have any questions, and we'll see you here next time. Bye!